All right, so 3.1 is on functions. This is all the vocabulary, Nate, on functions. Okay? There's a ton of vocabulary, but a lot of it is kind of like just different ways we can call one thing, okay? And you'll see what I mean. Ready for this, Joey? An ordered pair is a coordinate, okay? Kind of think like yesterday when we were doing what are the coordinates or what is the longitude and latitude of, say, New York City, and we were estimating that. That's what an ordered pair is. It is made up of two things. I just saw it. Yeah. It's made up of two things, an X and a Y, and it's alphabetical. The X value comes first, and then the Y value. So you're going to give me like how much left or right, and then followed by up or down. Make sense? Maddie, you okay with me on that? So remember, it's just alphabetical. I'm not trying to make your life miserable. Now, input. Input is simply this. Okay? It's simply your X values. Okay? So we have kind of think of like a vending machine. Okay? Everybody knows the vending machine downstairs by the cafeteria, or not cafeteria, by the gymnasium. It's got like milk in it, which is weird, or like muscle milk, or it's got like pirate booty, which is like the best thing in the world. All right. So a vending machine is a very good example of kind of like input output. So think about it this way. You put in your money into a vending machine, and then you put in a what? A code, right? Like X12 or like A12. And then it spits something out, right, Shayna? Okay, makes sense to you? You're like, yeah, I've done that before. Okay, so you put in a letter and a number. Okay, that's your input. And then your output is whatever you're supposed to get, right? So your input is your X values. It's whatever you put into the machine. And your output, this is going to be called your Y values. Now, there's a lot of different ways we could talk about it, okay? But I'm simply going to keep it as this. Your input is your X values, and it's your independent variable. Okay? Now, your output is your dependent variable. Okay? Are you guys all right with that? Annie, you okay with that? So far, so good? Not too difficult? Okay. Your domain. Your domain is just another way of saying your X values. Okay? So again, input, domain, X values are all the same thing. I don't know why we have different things, but I think it has to do with the different formats that I give it to you in. All right? So input, you're typically going to see in a table. Okay? Your domain is going to be on a graph. All right? Making your range your Y values. Now, we already talked about this. Independent variable. Okay, independent variable is kind of like what's going to drive the function, like what matters, okay? Kind of think of it like your age and your grade that you're in at school, right? So if you're like 15, 14 or 15, you are a freshman at Pencrest High School. Kind of makes sense to you? So time is typically an independent, and dependent would be like your grade. Okay, but again, independent variable is your x values. Okay, it's what you put in. It's your input. It's your domain. And your dependent is your y values or your y variable. Are you guys okay with all that stuff? All right. Now I will interchange the words input, domain, independent variable all the time. So you have to make sure you know what I'm talking about. All right. Range, output, dependent variable. They all mean the same thing. So I'll be interchanging them. Now, the last two, no, they don't mean x variable or your x variable or your input. All right. They kind of mean something a little different. A relation is kind of like a pairing of two things. Okay. Okay. And the two things are your inputs and outputs. So relation is kind of a mapping telling you where one thing goes. One thing goes to something else. So it's a mapping. And you'll see what I mean by that. So a relation, we're just putting two things together. We say this goes to that, and that's it. Okay? Now a function is a one-to-one relation. And then I'm going to give you a little cheat sheet. Joey, do you need to do jumping jacks? You sure? Positive? Do you need to do burpees? Push-ups? Air squats? Toe touches? Oh, I saw you getting a little tired over there. Okay. Just want to make sure you're like all jazzed up for this like me. Love this stuff. Are you lying to me? Because I'll send you an invite to come to a mandatory meeting tomorrow.
No. It's a lot of fun.
I like the enthusiasm. All right. So a function is a one-to-one relation. Okay. But in short, this is what you guys need to know. Ready for this, Nate? Okay. X values do not repeat. And that's the big thing. They don't repeat. All right. So let's look at all of this stuff. So functions can be represented in many different ways. They can be represented in tables, a mapping, lists, graphs, or equations. So down here, this is a mapping. Notice it uses arrows. It says 1 goes to 0, 2 goes to 1, 3 goes to 2, and 4 goes to 2. That's a mapping. It's physically telling me where it goes. So mapping is just a drawing or a diagram that's showing me where things are going. All right? Let's turn the page and look over here. Now we can start to see the difference between each thing. Okay? And the directions are asking me to tell whether the parent is a function. And here's how I do it. Okay, ready for this, Annie? We're only concerned about the domain. All right, so which one's the domain? Do you know? Yes, you do. Look at the list. What did I say was all equivalent? Which words? Okay, so I gave you a bunch of words at the start, right? At the top. So let me show you where I'm talking about. Up here. Yep. All of these, right? A bunch of them all meant the same thing, right? So I said we're only concerned about the domain. So find the word domain. What is that talking about? X values. Up there, we're talking about input, right? And output. So let's find those words. Input and output. Which one means the same thing as domain? Input or output? Input. So when I say domain, even though we only have input and output, you need to know that domain is talking about the input. So with the input, we only want to see one input going to one output. So how do I figure that out from this? Well, does everybody see how 0 has two arrows coming from it? Because 0 has 2 arrows coming from it, it means that it's being repeated. Because 0 is being repeated, A is not a function. Okay? It's not a function because that is being repeated. So I'm going to circle that. So far, so good, Maddie? Now, Maddie, over here in B, again, I have the input and output. So which one am I paying attention to, input or output? Input. Now look at your inputs, 0, 1, 4, and 6. Do they repeat? No, so guess what? This is a function because we don't have any repeated x values. Make sense? Nate, here, I don't have the words input and output anymore, right? But which one of these is my x value, right? Is it the first number or the second number? The first number, because it's alphabetical. So Nate, all of these that I underline, those are my x values. Do any of those numbers repeat? No. So this is a function. Starting to get the hang of it? Ellie.
Yeah.
Do any of these x values repeat?
Yeah, 4 does.
4 does. So I'm going to circle the ones with the 4. Because 4 is being repeated, it's not a function. Like,
Yup.
what's your take on E? Is it a function or is it not a function?
It is.
Why is it a function?
It follows everything it needs to be.
What is that? What does it follow?
So you see how it goes from 3, 4, 5, 6, 7, 8.
Okay, so you said 3, 4, 5. What is that? Is that my input or output?
Output.
All right, so the output. So you're telling me that the output is what matters in a function, correct?
Now it's the input.
It's the input. So which numbers do I need to be paying attention to?
-2, -1, 0. Oh, it's not right. It's not.
It's not a function because the zeros repeat. Let's look at F. Tyler.
What's up?
Not much. How are you doing?
I'm good. How are you?
Not bad, not bad. Tyler, is f a function?
No,
All right, let me ask you this, Tyler.
because 11 doesn't go into 15, right?
No, it doesn't matter. Tyler, let me ask you this. What values matter in determining if something is a function or not? Is it the x values or the y values?
X values.
X values. So let's look at your inputs, your x, right?
Yeah.
The oval on the left. Do any of those numbers repeat? Are there two arrows coming out of any one of those numbers?
No.
No, because each one of them only has one arrow coming out. This is a function, Tyler. Make sense?
Yeah.
One more time. The only thing that matters
X.
in determining if something is a function or not is the x values. If the x value repeats, okay, which was pretty easy to see, like in the one right above it that Mike did, the double zeros, notice it's being repeated, or if there are two arrows coming from it, it's not a function. Let's turn the page. So moving forward, okay, because there's many different ways a function can be represented. We have tables, we have ordered pairs, we have mappings, okay? And the other one was graphs. So what is the graph of a function? It is a visual representation. Okay? It's a visual representation of a relation or a function. Now, Joey, you ready for this? You got a pencil, right?
Yeah.
Thank goodness. All right. So here we go. I need to. Oh, that one's good. That is a good one. You guys at home and in the class, you're going to be using your writing utensil, your pencil. Maddie, you don't have a pencil? Oh, my heart was whole at 11:42 when I believed you had a pencil. And then at 11:43, you shattered it by telling me you didn't have a pencil. And I will go home and I will cry myself to sleep because you didn't have a pencil.
I'm so sorry.
Are you being sarcastic now?
No.
Oh my gosh. Now I'm going to even cry harder when I go home. Not because of the extreme cold that it is outside, but because you didn't have a pencil. No, it's okay, Maddie. I forgive you. All right. So what we need for this is we need a straight line, and that's your pencil. Okay? Mine up here is this. This is my straight line. Are you ready for this, Nate?
I'm ready.
To determine if something is a function given a graph, this is all we're going to do. You're going to take your straight line. So everybody take your straight line and put it down on the graph. All right? And it's going to be vertically. Okay, notice my line is vertical, not horizontal, vertical. Ready for this? Put your pencil down on your paper, Joey. This is mathematical. Put it down out of your hand. Lie it vertically, just like me. Ready? And what we're going to do is we're going to drag it across the graph. And I want you to notice something. At any point on my graph, there is only one dot that touches my blue line at any moment. Do you see that? Look, only one dot, 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 only one dot. Do we all see that? This passes the vertical line test. Therefore, it's a function. Let's go to this one. Do you see this? Ready for it, Nate? As I drag my blue line across, I stop. Do you see how my graph touches my blue line twice? Right there where I circled in red, and right there where I circled in red. Therefore, this fails the vertical line test and is not a function. You guys okay with that? So let's look at these. Take your vertical line, which is your pencil, drag it across your graph. Once your graph touches it twice, you stop. Grace, do you see why I stopped right there? Because it touched twice, right? Not a function. Ready, Shannon? See how it only touched once? Function. There we go. All right. You guys try. There are 4 problems right here. You guys try. All right, should have been enough time, right? Pretty straightforward. Maddie, what did you get for the first one? Function? Not a function. Function, conjunction function, function. Sorry, it's a great song. Great song. All right, yeah, it's a function. It passes the vertical line test. Jules. Jules,
Hi.
is number 2 a function? As I drag my blue line, does it pass the vertical line test?
I'm not too sure.
Well, does the U touch the blue line twice at any moment?
Yeah.
Where? Tell me when to stop.
Stop at 2.
No, touch twice, meaning the U touches my blue line twice.
Oh, then no.
No, so number 2 is a function. Katie, what about number 3? Function or not a function? Not a function, because it touches twice right here. What about number 4, Grace? Not a function? Why? Why not? Where does it touch twice?
Oh, wait.
It's a function. It only touches once. I see you, Joey. Watch you. All right. Any questions? No questions? All right. Domain and range, okay, can get a little tricky. All right. So I'm going to try and get through some of this stuff. Domain is all of your X values. It's your input. So whenever I give you a table, I'm just asking you to write down your X values. That's it. But when I give you a graph, it's a little trickier, and that's why I have to go over this. So in A, if we think of A is kind of like a bunch of balls like being suspended, if I turn on gravity and all of these little dots fall to the x-axis, meaning this would go to there. That one stays where it's at. That one falls to there, and that one falls to there. My domain would just be those numbers. So it would be -3, -1, 1, and 3, because that's where the blue lines fall to. My range is when I draw the lines to the y-axis. So they would be -2, 0, 2, and 4. And with a question like B, I do the same thing. All right, I'm going to draw my arrows to the x-axis. But because it's a smooth line, it's basically going to be, x is going to be between -2 and 3. And my range will be between -1 and 2. All right, and we are going to stop there, and I'm going to save these word problems for later. So